Okay, so the next concept will be the splitting of white light. So we know that the white light contains about 7 different colors, right? So definitely is red, orange, yellow, green, blue, indigo, violet. So that's actually a very easy way to memorize all these 7 different colors. So you just think of Roy. Oh, sorry, not Roy. Richard of York give birth in vain. Yeah, so this is how we memorize. This is how I memorize the different colors in the white light. Okay, so of course the red color has the longest wavelength of 700 nanometer. So orange, yellow, green, blue, indigo, and the last of all is your violet. So violet has a wavelength of about 400 nanometer. Yeah. So the violet has the shortest wavelength, whereas the red has the longest wavelength. So what happens when the white light enters the glass prism? So you can see, looking at this diagram, you notice that the white light, when you enter the glass prism, you can actually see the 7 different colors. Why is that so? Because apparently, right, the 7 different colors actually travel at a different speed. So when you travel at different speed, means that you actually bend differently towards the normal. So for example, red. If I draw a normal right here, you will see that the red actually bend towards the normal, but not as much as violet. So I can say that, oh, red light bends the least, whereas violet light bends the most towards the normal, of course. So of course, the next thing is, what can I say about the speed of light, of red light in the glass prism? The speed of red light in the glass prism should be greater. Whereas for violet, right, the speed of light of violet should be the smallest. So since different colors bend at different angles towards the normal, we can actually see the 7 colors separately. Okay, yeah, so just take note of one thing is that, okay, the speed and wavelength of the light changes, whereas the frequency will always remain unchanged. Okay, so let's take a look at all the different refractive index of the different colors. So for refractive index, for the different seven different colors, we actually have different refractive index. So if you look at red and violet respectively, right? So for red color, your refractive index actually is the smallest. So if your refractive index is the smallest, means that the speed of the red color, right, is the greatest. Okay, now you look at violet. So violet is 1.52. So you can say that, oh, the refractive index of violet is high. Then since the refractive index of violet is high, the speed of violet is low. So that's why you bend more towards the normal. Okay, for red light, you bend less towards normal. So that's the idea of the bending or the dispersion of your white color light in the glass prism.